sectors. So sectors is basically a section of circle. Ultimately, that's what it will be. So you will need to know two of the formulas. We might have to find distance from along an arc, so we will use circumference formula for that, which is 2 pi r. If we are going to find the area of a sector, then we are going, this is for arc length, make that little note right there, arc length. For area of a circle, it will be pi r squared. Okay, these are on your formula sheets. Shouldn't need to put them in any special place because you already have them on a formula sheet, so you're good. So here's the formula specifically for arc length. You will simply plug into this. So here we go. Arc length is the formula for circumference, 2 pi r multiplied by whatever the measure of that angle is over 360, because there are 360 degrees in a total circle. Okay, that's the formula you will use for arc length. The formula you will use for area of a sector will be this one. You will again use the area of a circle formula, so it's pi r squared, and you will do the same thing. You will multiply it by the measurement of that angle divided by 360. Okay, so basically what you're doing is you're taking the angle, dividing it by 360, which gives you whatever piece of the pie you're cutting off, and then multiplying it by the total lengths. So let's do a few examples. Example 1a, it says find the length of xy. So you should be on page 224 staring at this one. It tells us that our radius is what? 15 centimeters. Thank you for paying attention. 15 centimeters. So all I need to do is plug in and find out my angle measure. So what is my angle measure going to be on this one? 60. It gives it to you. So plug into the formula to find our arc length. So since we're finding arc length, we're going to plug in 2 pi r, which is 15, multiplied by the measure of our angle, which is 60, divided by 360. Really quickly, I could type this all into my calculator and get an answer. That would be the easiest way to do that. We want to make sure that we answer the problem according to the instruction. So if it says leave it in terms of pi, we do that. We leave it in terms of pi. So here I will not multiply pi out. Okay? So it's 2 times pi times 15, which is 30 pi, multiplied by 60 over 360. And when I multiply that all the way through, I get 5 pi for my final answer, and then I need a label. Since it was 15 centimeters, my answer will be 5 centimeters. So this is just a piece of the circumference, or a piece of the perimeter, if you were talking about a square or something. Okay, just a piece. On part B, it gives us just the information we need. The only information we need is the radius and the measurement of the angle. So in order to find these, I go through the information they give us and identify it. Find the length of the arc when it measures 75 degrees, and the radius is 4 feet. Again, just simply plug it in.
That was a start, huh?
Yep.
Okay.
We'll plug into the formula 2 pi r, which is 4. Multiply that by 75 over 360. There's really not much to it. Kinsey, if you want to come back in like 5 minutes. Okay. Multiply that all out. Again, we're leaving it in terms of pi. So 8 pi multiplied by 75 over 360. And that will give us our answer, our total answer. I'm going to leave it in fraction form because otherwise I'm going to write a repeat end. I don't want to. It will be 5/3 pi feet. Okay, that one was measured in feet. Questions? Okay, example 2 does the exact same thing. We just plug into area of a sector formula. So example 2a, we find the area of the sector XOY. Notice how they named that on part A. We're finding the area of the sector XOY. So to find that, we need the angle measure, so the angle measure will be what? Example 2A, what is the angle measure? 95. See, we do know. We just need to be screamed at sometimes.
Wait, Mr. Gannon, did you
Yes,
say that you don't want to repeat in?
I don't want to repeat end,
So,
personally.
Do you just round it up, or?
No, I would write it as a fraction. 5/3. On part A again, what is the radius? 12 inches. Okay, so 95 degrees and 12 inches. I plug in. Here we go. Pi r, which is 12 squared, multiplied by the measure of the angle, which is 95 over 360. Using my calculator, I can get these answers really quickly. I'm going to change that 12 squared already to 144. See if it tells me to leave it in terms of pi. It does. So I get, at the end, 38 pi inches. And because it is area, it is inches squared. Don't forget that label. Mainly, it's just how to set it up. The rest is pretty well calculator work for most of you. Okay. Part B. We need to, again, identify the radius and identify the measure of the angle. So, the radius for this one, we'll identify as I read it. Find the area of the sector with an arc measure that is 174 degrees. The radius is 13 meters, and we can use that information to plug into our formula. So here we go. Pi r squared is the beginning, so pi, and our r is 13 squared, multiplied by the measure of the angle, 174, divided by 360. Bada bing, bada boom, multiply that all out. 13 squared is 169. Multiply that whole thing out, and I get a really large fraction. 4901 over 60 pi meters squared. I know somebody's going to try to write this down as a decimal approximation. Do not write things as decimal approximation unless they tell you to. Okay? If they tell you to round it, of course, go ahead and round it. But in this case, they don't. So I'm going to show you how to do this in your calculator. Because we're leaving it in terms of pi, I'm not going to multiply pi out on my calculator. So here we go. It says 13 squared, so I have 13 squared. Let me get a little bit better of a view here. Okay, there you go. Maybe that'll make it a little bit better. So that says 13 squared. We're going to multiply that by 174 over 360. So here we go. In parentheses, 174 divided by 360. And then I'm closing my parentheses. I press enter. It gives me this business right here. I need to convert that to a fraction because I can't write that down. I mean, I guess I can. I can write 81.683 with a repeat end if I wanted to. That's an exact answer. But if I was going to write this down as a fraction, like the book has been, I can press math, fraction, and it'll convert it back for me. 490160. And then I have to remember to put my pi back in there because I never multiplied by pi. Now, if it doesn't tell you to keep it in terms of pi, that's easy to do. You just press second and this raise arrow, and it'll put a pi on your calculator. Okay? And it'll multiply it all out for you. Questions? Cool. On example 3, this is pretty much our last example. It's finding an unknown from given information. So they'll give you everything except for one variable. Okay? And they'll say find that variable. So in example 3, it says find the radius of the circle given. They give us the area is 100 meters squared. And they tell us that the angle measure is 246 degrees. Okay? And we have to find our radius. We don't know what our radius is. So I take the area of a sector and I plug in what I know. I know the area is 100. I know that pi is just going to be in there. I know that the radius is r, but we don't know what it is. We're going to solve for it here in a second. And we know that the measure is 246 divided by 360. And I start to solve this the best way I can. Okay? I'm going to get r by itself. So I'm going to use the commutative property to rewrite this. 100 equals, I'm going to put r up front, and then I'm going to take 246 over 360, and I'm going to multiply it by pi. I'm going to show you what that looks like in your calculator. I take 246, I divide it by 360, press enter. There's the number. Okay, 0.683333, blah, blah, blah. Okay, I don't need that right now. It's not that important. I need to multiply it by pi though. So I'm going to press multiply, second up, and that multiplies it by pi for me, and that gives me a number. Leave that in your calculator. Okay? For right now, I'm going to write a decimal approximation on my paper so that you can see what I'm doing. So it's the radius multiplied by approximately 2.15. Okay? How do I get rid of the radius being multiplied by 2.15? Divide it, right? 2.15 divided by. So that gets rid of that. My radius is now by itself. So I take 100, I press 100, I divide by that last answer, and this is how I get it. I press second, the negative button pulls up the last answer. So 100 divided by second, the negative button is ands, and it pulls up your last answer. You press enter, it spits out a number. If I want to write an exact answer, I convert it to a fraction, and apparently this is a number that we don't know how the end is. So let's see what our problem tells us to do. It says to the nearest hundredth of a meter. So I'm going to round this to the nearest hundredth. 46.58. I'm going to write approximation in here. 46.58. If your calculator won't convert it to a fraction, it's probably because it can't be written as a fraction. Okay? Questions? Yes. What's the book have? Oh, I know why now. Here we go. This is r squared, guys. Thanks for correcting my formula now. How am I going to get r by itself now? If r is squared, how do I get rid of it? Somebody said it. Square root. So what I do to one side, I must do to the other, right? So now let's take that number and square root it. So second square root, second answer, press enter, 6.825. So r is actually 6.83 if you round it properly. 6.83 what? Meters. And that's your final answer. Thank you for catching that.